So, redox reactions. Let's look at one. Alright, so here's an equation. First of all, would anyone want to take a guess why I wrote H2O above this arrow sign? Yes. This means water is a catalyst. Occurs in our reaction happens in presence of water. This reaction doesn't occur without water. In order to actually get oxygen to bind with iron and make it rust, it needs the help of H plus ions to come in here and strip electrons from the iron, causing the oxygen to then switch and bind to it. You can mostly ignore this. It's just a notation we use. Iron. What state is it in? Solid. O2. What state is it in? Gas. And Fe2O3. What state is it in? What is Fe2O3? What's the common name for it? What is the proper name for it? How would you name this chemical? So this is iron, oxygen, molecular oxygen would be more accurate, but oxygen is how you name it. And what's the name of this chemical?
Was it tattooing?
What? This is rust.
Oh, I thought rust was.
Rust is Fe2. What's the proper name of it? How do you name this chemical? I've used this exact equation I don't know how many times. And mentioned the name of this chemical I don't know how many times. Iron 3 oxide. More commonly called simply rust. Is rust a solid, liquid, gas, or aqueous? Solid. What type of overall reaction is this? Synthesis. What's the balanced version of this equation? What should the prefixes be? If you try to, and it's a good starting point. If you put 2 here, you have iron balanced, but then you have oxygen is 2 and oxygen is 3 over here. You know from this, you know you're going to have to put a number here, which is going to screw up how many iron you have.
So if you did 2 on the right side for the whole entire thing, and then you did 4 irons and 3 oxygen.
So balancing the oxygen first, 2 over here gives you 6, 3 over here gives you 6. Now we can balance the iron. 4 over here, so we need 4 over here. What is being oxidized? Iron. It should be very easy in knowing it's being oxidized. We're putting oxygen on it. Another way is this is going from what is the oxidation state or number? By the way, oxidation state. It's the same thing as oxidation number. These are two synonyms of each other. You can either call it oxidation number or oxidation state. What is the oxidation number for iron? Over here. No. What is the very, 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 very first rule in oxidation numbers? What about oxygen? What's oxygen's oxidation number? What's the very first rule? Nope. What is the very, very first rule? Elements are always zero. This is elemental oxygen. So its oxidation state is 0. Iron, oxidation state is 0. It is an element. Elements always have an oxidation state of 0. What is iron and iron 3 oxide? Plus 3. What is the oxidation state of oxygen? -2. Oxygen is always -2 unless it's in peroxide. So iron is going from 0 to +3. So it's going from 0 to +3. That means you are increasing the oxidation number by 3. So that means it's oxidation. What is being reduced? It has to be what's left. Oxygen is going from 0 to -2. So we are subtracting 2, so that means it's reduced. It's reduction. What's being oxidized is our solid iron. What is being reduced is our O2. In this case, we're looking at the reactants. I'm writing it in form of reactants. Again, or this side of the arrow is reactants, and this side of the arrow are products. The element are the specific element would be iron and oxygen. Iron is being oxidized, but if we look at the reactants, it's the oxygen, the O2 molecule. So what is the half reaction for oxidation? So iron is becoming iron 3+. How's it doing this? How's it getting a 3+ charge? It's losing electron. So here we can imagine this as a box that has 3 electrons in it, and it is splitting off into a 3 plus along with 3 electrons. They're separating, it's breaking up. So on this side they're all together and they're all bonded together. The 3 electrons are attached with the iron, and then it's breaking apart, so we put the electrons on the right side. What about the half reaction? For the reduction, we know our chemical involved is O2, so it's going as O2, and it's being converted into O2 negative. So how do you get an, and you need to balance it by putting a 2 here. It's going to be gaining 2 electrons. It's getting these 2 electrons, making it have a negative 2 charge, or a 2 negative charge. So we put it on the left-hand side. This is where oxidation comes from. It's the fact that iron is literally being oxidized. We're actually adding oxygen to it. Almost all redox reactions involve oxygen, but not necessarily. For ionic, or I should say, for ions, there is no difference between the concept of charge and oxidation number. Oxidation number and charge are the exact same thing for ions. So if you remember your ionic rules for finding charges, it's the exact same thing. So looking at NaCl, actually let me choose magnesium oxide. Magnesium has a charge of 2 plus. Oxygen has a charge of 2 negative. And so the oxidation number is +2 and -2. The convention is charges have the sign on the right. Oxidation number has the sign on the left. So if you're dealing with an ionic compound, just figure out what the normal charges is. Don't worry about the complicated rules for oxidation number. What is the name of this chemical? Ammonium. Or ammonia. It's what you use to clean with at the house. Don't confuse it with ammonium, which is an ion of ammonia. Is this ionic or covalent? Without looking up the actual values. Without knowing the chemical, the values, the electronegativity, you should recognize this is two nonmetals bonded together. Two nonmetals usually are almost always covalent. Whereas ionic is a metal and a nonmetal. They're on opposite sides of the periodic table, so this should be covalent. You are right that hydrogen is 2.2, nitrogen is 3.04, which gives us a difference so the En difference is equal to 0.84. That is polar covalent. Polar covalent is between 0.5 and 1.7. So we can't strictly use charges to figure out what the oxidation state of nitrogen is. If you treat this as an ions, you would see we have a H+. Nitrogen usually becomes 3 negative, right? And that should be nitrogen. Nitrogen usually forms a 3 negative ion, but this isn't ionic. What would be the oxidation state for nitrogen? It is 3 minus. It just happens to work out that way. Our rule is hydrogen is always +1. We know that the sum of these oxidation states have to add up to 0. So I have whatever N is, plus 3 plus 1 charges, must add up to 0. So that's nitrogen plus 3 has to equal 0. Nitrogen is -3. So often the case, the ionic charge, if it was ionic, does match the oxidation state or number. Oxidation number / state is a value that is derived by assuming all bonds are 100% ionic. We know this is covalent, so the bonds, the electrons are actually shared. Let's do an exception. So when is hydrogen not +1? Yes. So lithium, here lithium is group 1, and that's stronger than the rule for hydrogen. So it gets a +1 charge. Hydrogen are not charged, oxidation number. Because these have to add up to 0, this means this is -1. Another way of looking at this is lithium, is this ionic? This would be called lithium hydride. Is this ionic? So the En for lithium is 0.98. Hydrogen is 2.2. The difference in En is 1.22. Yeah, and this is another exception. There's way too many exceptions. This is classified as ionic. Why? Google that. Why is... I'm pretty sure I know the reason. It's hydrogen. Hydrogen is an exception to almost everything. Why is lithium hydride ionic? I want to say... Let's see. I'm curious. No, I'm seeing mixed results. It does have both properties of covalent and ionic. So it is very strongly polar covalent. I want to add to the solubility rules another exception. That is not found on y'all's notes. Let me pull up the PowerPoint. I believe it's the exact same as the PowerPoint, except for there's one error in the PowerPoint. So what's in yellow is wrong. But there's something missing from this solubility rules. Let me see if I can find a better solubility rule that includes it. It's for acids. What's the definition of an acid? What's the definition of an acid? a compound that produces H plus ions when dissolved in water is a loose definition. So this is something that should be included. All strong acids, the major exceptions are for very high molecular weight compounds. Dissolve in water. So, for example, H3PO4. This has two ions. It has an H plus ion, and it has a PO4, 3 negative ion. Thus, it has an H plus ion, which should scream to you acid. And acids dissolve in water. If you use the solubility rules, it will say this doesn't dissolve in water. But by definition of an acid, it does. And I don't know why it doesn't list it. Like, I'm looking up every single general solubility rule, and it doesn't mention acids. And every single one says this is insoluble. Finally found one that actually mentions it. So, phosphates. All phosphates and carbonates are insoluble unless they have an Na+, K+, or NH4+ cation. However, many acid phosphates are soluble because acids are generally all soluble. Let's see if y'all can figure out this. What is the decomposition of hydrochloric acid with oxygen? What would be the equation for it? this is really, you can almost ignore the word decomposition. So what is hydrochloric acid mixed with oxygen? The reason why you can ignore the decomposition is, so if it's just the decomposition of hydrochloric acid, what is the equation for hydrochloric acid?
Just be HCl.
Yes. So remember our rules. If it has hydro in the front of it, then it's just elemental chlorine mixed with hydrogen with or hydrogen with chlorine. So when hydrochloric acid decomposes, it decomposes into H plus and Cl ions, and eventually we will get hydrogen gas and chlorine gas. However, if oxygen is next by, hydrogen would rather attack the oxygen than it would be would attack itself or combine with itself. So moreover, we have HCl with oxygen and makes what?
Plus O2, would it make water and chlorine?
Yes. All right. Anybody get anything different? What's the balanced equation? Can you even balance this? Yeah, you should be able to balance it, but the equation's wrong. What's wrong with it? Allie, you've been on a roll. Carlos, what's wrong with it? Look at the left-hand side and look at the right-hand side. We done something special on one side, but why didn't we do it on the right? The what? What do you add to it?
Oh.
It's a diatomic molecule. Very important that you know your diatomic molecules. Cl by itself is an ion. Cl does not exist by itself. Oxygen does not exist by itself. It's always O2. Now you should be able to balance it.
Balance it with the 4 HCl plus 2 O2 goes 2 H2O and 2 Cl.
So you said 4, just say the prefix numbers.
4, 2 and 2.
Yes. So balancing the oxygen, that's 2 and 2. We need 4 of these. But you put a 2 here?
Oh, no. It's already got O2.
Yep. So hydrochloric acid acids are always going to be aqueous. That should be on the solubility rules. Acids are almost always aqueous by definition of an acid. So I think I've mentioned this before. To be honest, I don't understand this fully. Water, actually, I believe, is constantly breaking apart into H plus and OH ions. Is constantly doing this, are loosely doing this. What I think is happening is one of the hydrogen, so we're bonding like this. Whenever, because there's a pair of electrons here, a pair of electrons being shared, whenever one side is sharing the electrons, and this becomes more negative here, and this hydrogen gets this electron, so oxygen is going to get slightly negative, this becomes slightly positive. This is actually going to have, how would that work? I think one of these hydrogens gets pulled farther away somehow. And it acts as if this is H plus and OH negative. There will be another charge right here. But I can't visualize how that works. I think this is somehow you can treat water as it being an acid and a base at the same time. But acids, this H plus is always able to strip away in the presence of water. Oxygen, O2, is a gas. Chlorine is a gas. And water is a liquid. So that's the balanced equation. What is being oxidized? So if you remember on our periodic table of EM values for oxygen, the EM value was, I believe, like 3.0. Fluorine was what? 4.0. It has the highest value. And what was chlorine? Was it 3.0? 3.5, I thought. Let me look that up. I don't have my periodic table with me. Chlorine is about 3.16. Oxygen is 3.44. I had it backwards. And that's a bad analogy already. You get me mentioning it. So what is chlorine in this? Or what is the oxidation numbers? So we have hydrogen, it would be what? +1. Again, definition of an acid, it always produces H plus ions. Chlorine would be -1. Oxygen would be
it'd be 0.
0. It's an element. Chlorine would be 0. Hydrogen, so this is covalent. So we need to use our covalent rule. What is oxygen? -2, which means the hydrogens to balance out the equation. And also hydrogen always +1 unless it's peroxide. So hydrogen and hydrogen never changes. That means hydrogen is called the what? Spectator ion. it stays H plus in solution. And I was saying up here, you can think of water as disassociating in H plus and OH ions. So what is being oxidized? Well, we see oxygen is going from 0 to -2. That means it's being reduced by -2, which means chlorine is going from -1 to 0 by adding 1. Chlorine is being oxidized. Oxygen is almost always the reducing agent. Or oxygen is usually the oxidizing agent, meaning it's going to be reduced. So oxygen is usually the oxidizing agent. Meaning it's reduced. This isn't true always. Reason why I was looking this up earlier, fluorine is a better oxidizing agent than oxygen. I was thinking chlorine was too, but I was wrong. Chlorine has less EN. Fluorine is the #1 oxidizing agent. We really should probably be calling this how would that be? Fluorization? But fluorine is very toxic and we don't usually use it as much as oxygen. So that means what is being oxidized I was spelling this correctly. Yeah, I don't think so either. Is HCl. And what is being reduced is O2. If you want to be more specific, it's the chlorine, the Cl negative ion. And it's the O2. There's no way other to put it as there's no ion for it. But the reactant being oxidized is HCl. So what would be the half reactions? So for half reactions, we're going to be looking at it in the ionic form. So we have the equation HCl with O2 makes chlorine and water. I'm trying to see ionic. The only thing ionic in this whole thing is this over here. What's the best way of doing it? This would be H plus chlorine negative. In this scenario, you have to treat water as being ionic. But I don't like that. Usually you don't do this. I was trying to simplify H plus. The half reaction regardless, you now can remove the spectator ions. I don't really like this. To do the half reaction for oxidation, it's just chlorine negative. It is losing electrons, so it's becoming chlorine. That should be an arrow. It's giving up an electron. Bouncing it here. So aqueous gas. And for the other one, real quick, it'd be O2. It's gaining electrons to become, and the only one is OH, or O2 negative. Test is probably going to be Tuesday. You just have to make it up. You might be able to just take it Wednesday during class.